Okay, so chapter 10, that's what we'll be discussing today. And chapter 10 has to do with the whole concept of energy and heat and all that good stuff. And what I'm going to do here is, let me get rid of this here from another class. All right, so energy, what do we mean by this term energy? Energy is, by definition, the capacity to do work. And this begs the question then, what is work? Well, work is basically what happens when force is applied to an object and the object moves a distance, right? So if you push or pull, which is what force is, a push or pull. If you push or pull an object and somebody says, oh, somebody said something, we didn't finish chapter 9? Oh, we finish chapter 9 first and then do chapter 10. That's what I said, if I remember correctly. Right, okay. I apologize for that. So what did we were working on the assignment in chapter 9?
Yes, we went to question 12.
All right, thank you. I apologize for that. I don't know, for some reason I just thought that we finished chapter 9. So I'm sorry about that. Let me go back to the assignment for chapter 9. Okay, chapter 9. So let's see how far we got into. Okay, so let's see. Chapter 9. How far did we get into chapter 9?
We stopped at question 12.
12?
Stopped at 12.
Oh, okay. So we did not do 12.
Correct.
Okay, all right, good. All right. So let's look at question number 12. And question number 12 talks about the reaction between calcium hydroxide and hydrochloric acid. Again, fortunately for us, they gave us a balanced equation. Let's see. Okay, thank you, Ms. DeGraw. Okay, so question 12, they gave us a balanced equation. And the question says, if you spilled 6.3 moles of hydrochloric acid, and then you put 2.8 moles of calcium hydroxide on it, which substance is the limiting reactant? I think this is our first limiting reactant type problem, so let me explain how this is done. So what I would do is, there are several ways actually, if you look in different textbooks and so on, there are different ways of doing this. My way, which I prefer, is that we start off with the amount of each reactant. So in the case of hydrochloric acid, 6.3 moles of HCl. And we try to figure out how much product you expect to get based on that, right? So, of course, in order for us to determine how much product, and you could use any one of these two products right here, I'm going to use calcium chloride, right? So basically, the first thing I'll do is look at the mole ratio between the hydrochloric acid and the calcium chloride. And as you can see, it's a 1 to 2 mole ratio, right? So I would put 1 mole of calcium chloride above as the numerator, and 2 moles of HCl down below as the denominator. And then I'll work out what that is. So that would be 6.3 divided by 2. So that would be 3.2 moles of calcium chloride, all right? And then I'll do something similar starting off with the 2.8 moles of calcium hydroxide. And I will multiply that by, again, looking at the mole ratio, this time between the calcium hydroxide and calcium chloride, that would be a 1-to-1 mole ratio. So 1 mole of calcium chloride would be above calcium chloride, and 1 mole of calcium hydroxide would be below. And according to my calculation, which is a relatively simple one, the moles of calcium chloride based on that would be 2.8 moles. And I just realized I made an error here. This should be calcium chloride as well. Okay, so somebody just say something in the chat. Oh, yes, Mr. De Jesus, yeah, you'll be able to resubmit your assignment, especially, I thought we were finished assignment 9. So I think I probably need to make changes the Dropbox deadline date. Anyway, so the next thing I would do is I would compare these two numbers, right? And the one that's smaller is 2.8 moles, right? Which means that the calcium hydroxide will be the limiting reactant, because based on the calculation here, you cannot get more than 2.8 moles of the product based on the amounts of the hydrochloric acid and the calcium hydroxide. So the calcium hydroxide would be the limiting reactant because based on the calculations, it would produce a lower amount of product. All right. Okay, any questions about this? Any questions? Any questions?
Yes, do we only round to the 10th decimal place? Because when I was doing the homework, for some reason, I just couldn't remember, so I was just doing whatever.
Okay, so the reason why I round off to 2 sig figs here and here is because I start off with 2 sig figs here and there, right? So if you remember when you're multiplying and or dividing, you round off according to the lowest number of sig figs. The 1 and 2 here and the 1 and 1 here are not measured numbers, so we do not use those to determine the amount of sig figs you round off your final answer to. All right? So I hope that answers your question. Okay, any other questions before we move on to the B part? Any other questions? All right, so let me clear this here. And in the B part, they're asking how many moles of excess reactant remain. Now, we know that the limiting reactant is the calcium hydroxide, right? In fact, let me write this down here, 2.8 moles. 2.8 moles of the calcium hydroxide, all right? So the question is asking how much of the excess reactant remains. Now, the way we go about solving that is that firstly, we need to determine how many moles of the excess reactant reacted, right? Which is a hydrochloric acid. So this is what I would do. I would find the mole ratio between the hydrochloric acid and the calcium hydroxide. And that's a 2-to-1 ratio where you're gonna have 1 mole of calcium hydroxide down here as the denominator. Up here, you're gonna have 2 moles of HCl, all right? So that would give 5 point, hold on. Which reactor was the limiting reactant? I'm sorry. From the first part.
The limiting reactant was the calcium hydroxide.
Okay. Let me just check something here. Okay, good, all right. I thought I was going in the wrong direction in this calculation. All right, so if we do the calculation for the amount of HCl that will react, that would be 5.6 moles of HCl, right? So this is the amount of HCl that reacted. What the question is asking for is the amount of HCl remaining. So amount of HCl remaining will be the original amount of HCl that you start off with, which would be 6.3 moles, minus the amount that reacted, which is 5.6 moles, and that would give 0.7 moles of HCl remaining. All right? And that's how we do the B part. All right? Any question about this? Any questions? Any questions? All right, any questions out there in Zoom? Okay, so let me clear this, scroll down. Oh, that's it for number 12, okay. So let's look at number 30. It says aluminum oxidized according to the equation, and it gives you the equation, and it says powdered aluminum, and they give you the amount, is placed in a container containing a certain amount of oxygen. Again, the question is asking, what is limiting reactant? All right. So based on what we did in the previous example or previous question, how would you guys approach this? You can feel free to look at the example that we just did earlier. How would you do this problem? What's the first thing you'd start off with?
You're going to start with the moles of powdered aluminum.
Okay, so 0.048 moles of the aluminum. And what would you do with that? In other words, what would you multiply by here? What would go up top here as the numerator? And what would go down here as the denominator?
3 moles up top of
3 moles
oxygen.
of oxygen, okay? No, well, actually, no. Because remember the question is asking for the amount. The question is asking which is the limiting reactant. If you remember the example that I worked earlier, I was finding the mole ratio between the reactant and the product. Right? So I wouldn't use oxygen because oxygen is another reactant if we're using that method. So what would you use instead? What would go up top here?
2 moles of aluminum oxide.
Aluminum
2 moles of aluminum oxide.
oxide. And what goes down here as a denominator?
Four moles of aluminum.
4 moles of aluminum. Very good. So when you work this out, you're gonna get 0.024 moles of aluminum oxide. Okay, what's the next step? What's the next step? Again, look at the example that we did earlier.
You do the same thing with the moles of oxygen.
Okay, so we start off with 0.030 moles of oxygen. And what do we do with that? What do we multiply that by? What goes up top?
You put 2 moles aluminum oxide on top,
2 moles of aluminum oxide above,
and then 3 moles of oxygen on the bottom.
3 moles of O2 below. So that is going to give you 0.020 moles of aluminum oxide. Then what? What's the next step?
You figure out which one's the limiting, which is the oxygen.
I'm sorry?
Figure out which one's the limiting reactant.
How do you do that?
See which amount of the moles is the smallest.
Right, so we compare these two and we see that this one is lower in value. So therefore that means that the oxygen would be the limiting reactant because that produces on paper the lower amount of product you expect to get. All right? And that's it for number 30. Any questions about this? Any questions? Any questions? Alrighty, so let me clear this. If it's okay, can I clear it? All right, so let me clear this. And let me scroll down. Oh, there's a B part. Okay. How many moles of the excess reactant remain? All right, so I shouldn't have deleted that. I think I'm going to need some information. So how would you tackle that problem?
You start with the limiting reactant, which is the oxygen.
Okay, so let me, and that was 0.030 moles, right? Okay, of oxygen, and then what do you do with that? What do we multiply that by?
The bottom would be the 3 moles of oxygen, and the top would be the 4 moles of aluminum.
Okay. So that would give 0.040 moles of aluminum reacting. Oops, aluminum reacting, all right? Okay, I'm hearing some noise in the background. Funny. Please make sure you're muted if you're not saying anything. Okay, what next? Now remember, this is the amount of aluminum reacting, right? And the question is asking how much of the excess reactant, which is the aluminum, remaining. So how would you find out the amount of aluminum remaining? Okay, let me see. Somebody saying something in the chat. Subtract it from the original amount. Okay, subtract. Okay, somebody's asking another question. Is reacting and reacted the same? Yeah, basically, yeah. Okay, so somebody, Miss Cole, is saying that we subtract, and I'm presuming she's talking about this here from the original amount. So, what's the original amount? 0.0 what?
48.
48 moles of aluminum, and you want to subtract from that the 0.040 moles. So the answer becomes 0.008 moles remaining. And that's how that is done. All right. Okay. Oh, somebody's saying something. Yeah, let's see what this is. Oh, thank you, Miss Cole. Thank you. Okay, and that's it. That's the answer to the B part. That's the amount of excess reactant that will remain. Okay, any question about this one? Any questions? Any questions? Okay, let's move along. Let me clear this here. Okay. Again, same idea, but this time the equation given is not balanced. So we have to take care of that first before we can even do anything else, right? So let's balance this equation. How would you go about balancing this equation here? Well, okay, somebody is chatting online. Let's see. Okay, so this person, a 2 in front of, is suggesting we put a 2 in front of the zinc sulfide, which I agree with. Put a 2 in front of the zinc oxide, which I agree with also. And then what else? A 3 in front of the oxygen, I agree with that. And what else? Is it balanced? A 2 in front of the SO2, I agree with that as well. And now the equation is balanced, all right? So that we need to take care of that first before we can even do anything else, all right? So now that we have done that, the question says if 1.72 moles of zinc sulfide is heated in the presence of 3.04 moles of oxygen, which is the limiting reactant? Okay, so based on the previous 2 questions, you should be able to tell me what to do with this one. So let me hear it. What's the next step? Hmm. 1.72 moles of zinc sulfide, right? Okay, what do we do with that? What do we multiply that by? What goes above and what goes below? Okay, somebody's chatting online. Below would be 2 moles of zinc sulfide. I agree with that. And that would be Miss Cole saying that 2 moles of zinc sulfide. And what goes above as the numerator? Okay, 2 moles, and somebody just said some 2 moles of zinc sulfide. And another person said something, hold on, let me see. Okay, so 2 moles of zinc oxide is what I would do. Now, somebody was suggesting 3 moles of oxygen. Not according to the method that we're using, because basically our aim at this stage is to find out how much of the product or products, or one of the products that you would get starting with 1.72 moles of the zinc sulfide. And let me just say, you could just as well use the sulfur dioxide in this calculation as well, all right? But we're choosing to use the zinc oxide, all right? So, based on the calculation here, this will give you 1.72 moles of zinc oxide, all right? So what's the next step? Anybody? Okay, so 3.04 moles of O2, right? And what do you do with that in that case?
Three moles, O2 on the bottom.
3 moles of O2 above, and what goes below?
Should it be the bottom?
I'm sorry, the bottom. Yeah, you're right. You're right. 3 moles of O2 below, and what goes above?
2 moles of zinc oxide.
Exactly. So let's do that calculation. So 3.04 times 2 divided by 3, and according to my calculation, this gives 2.03 moles of zinc oxide. All right, and let me just see something here. Somebody's saying maybe the same thing. Okay, so yes, okay, yes, Miss Cole just said the same thing. All right. So, what next? Now that we have done those 2 calculations, what's the next step? Okay, so the 2 that's lower, this one is lower, right? Which means what? That's the lower. This is the limiting reactant. All right? And that's it for the A part. All right? Any questions? Any questions? Any questions out there in Zoom? Okay, let me go ahead and clear this. And scroll down. How many more? Okay, same idea as the previous question. How many moles of the excess reactant remain, right? So the limiting reactant was the oxygen, right? I'm sorry, the zinc sulfide, right? Okay, so come on. So we're gonna start off with the zinc sulfide. How much of the zinc sulfide was it? 1.72 moles of the zinc sulfide. Okay, so what we're gonna do with that now? That's a limiting reactant, right? So what are we going to multiply that by? To get the amount of excess reactant that's reacting. In other words, what goes up top here and what goes down here as a denominator. I'm sorry? The two. Zinc sulfide? No, you mean 2 moles of zinc sulfide below. Okay. Okay, and what goes up above as a numerator? You what? 3 moles of oxygen. Okay. So let's do that calculation. 1.72, oops, 1.72 times 3 divided by 2. So the calculation that I got, the results I got is 2.58 moles. Okay. So what do we do with that number? This will be the moles of oxygen, by the way. Okay, so what do we do with that?
Track that from the 3.04 moles.
Okay, so because this is the amount of oxygen that reacted, right? So to find the moles of oxygen that remain, that would be the 3.04?
Yes,
3.04 moles. That was the initial amount, and then 2.58 moles of it, 58 moles of it reacted. So the difference between those two will give you the amount that remained, minus 2.58. And according to my calculation, 0.46 moles is the amount of oxygen that remain. All right? Okay. Any question about this one? Any questions? Any questions? Let me clear this. Scroll down. Okay, now this one is a bit more challenging compared to the ones that we just did because, well, for one, the equation is not balanced, so we need to balance it. And then in the case of the A part, they gave you the masses, not the moles of the reactors, right? So let's concentrate first on balancing the given equation. So how would you go about balancing this equation? Anybody? Put a 2 in front of the KBR according to one of your classmates online. Let me see who said that. Miss Co again, okay. And it, oh, I'm sorry.
I'm sorry, 2 in front of the KCL.
Put the 2 in front of the KCL as well. And I think that takes care of everything, right? So now the equation is balanced, right? Okay, very good. Now, the question says when 0.855 grams of chlorine and 3.205 grams of potassium bromide are mixed in solution, which is a limiting reactant? So it's asking the same thing that we were looking at in the previous 3 problems, right? So in this case, there's an extra step, or I should say maybe an extra 2 steps that we have to take because we're not given the moles of these substances, we're given the grams, right? So what we have to do is convert the given grams of the different reactants, to moles. So 0.855 grams of chlorine, we have to convert to moles. So we're going to put 1 mole of chlorine above as a numerator, and down here would be the molar mass of chlorine, which would be 35.45 times 2, so that will be 70.90 grams of chlorine, all right? So that goes with that, right? And then we look at the mole ratio now between the chlorine, and we could choose any one of these 2 products, right? So I'm going to choose the chloride, the potassium chloride, for the next conversion factor. And I would put, okay, it's a 1-to-2 ratio. So I would put 1 mole of chlorine down here as a numerator, and above I'm going to put 2 moles of potassium chloride, all right? And then we work that out, so that's 0.855 divided by 70.9 times 2, and according to my calculation, I got 0.0241. And please correct me if I'm doing these calculations wrong, because I've been known to make errors. This should be potassium chloride. So KCl, okay. So that's basically that, starting with the 0.855, and then we do something similar with the 3.205 grams of potassium bromide. Again, we have to convert that to moles. You're gonna have 1 mole of KBr. And down here, the molar mass. Now, I'm feeling lazy, so I'm just gonna use my trusty molar mass calculator. Unfortunately, you guys won't have access to in your tests. Let me go here. And then scroll down. Okay, so KBr. BR. And let's see what the molar mass is. 119.00. All right, so I'm going to put that down here. 119.00 grams of KBr. All right. Okay, so that's converting from grams to moles. All right. The next step is where, again, we look at the mole ratio between well, in this case, the KBr and the product potassium chloride, right? And that is a 1-to-1 mole ratio, or 2-to-2, same difference. So here we're going to put 2 moles of KCl above as the numerator and 2 moles of KBr down here as the denominator. So 3.205 divided by 119. Oh shoot, I did something wrong. 3.205 divided by 119. Okay, I got point and then multiplied by 1 basically. And I got 0.0269 moles of KCl, right? And then we know what we do next, right? What do we do next? And how do we tell which one is limiting? Huh? The one that gives you the lowest amount of product, right? So that means that the limiting reactant would be the chlorine. All right? And that's basically how that is done. Okay, any questions on this one? Any questions? Any questions? Any questions out there in Zoom? Okay, so let me clear this. And scroll down. How many grams of each product are formed? Oh shoot, I shouldn't have, keep forgetting, I shouldn't have, hold on, I should be able to recover this. Oh, there you go, okay. Learn something new every day. All right, so the question is asking how much, let me see here. Oops. What did I do? How many grams of each product are formed, right? So, let me do some erasure here. Okay, now we know the moles of one of the products being formed, and that would be the potassium chloride. So calculating the grams for that would be relatively easy. Okay, all you have to do is say that the mass of KCl, now we have to use a smaller value, right? Because that's what you'd expect to get. The mass of potassium chloride formed would be equal to the moles, which is 0.0241 moles, multiplied by the molar mass. So you're going to have 1 mole of KCl up down here and the molar mass. So again, I'm going to go to my molar mass calculator and I'm going to put the formula for KCl here. And I got 74.55 grams. So I'm going to put 74.55 grams for the potassium chloride. And let's see what I get. 0.0241 times 74.55. So the according to my calculation, rounded out to 3 sig figs, that would be 1.80 grams of potassium chloride. All right. So that answers part of that question, because the question is asking for the mass of both products, right? The question says how many grams of each product are formed, all right? So we know the mass of one of the products formed. So the question is, what's the mass of the other product? Now, the other product is bromine. And based on the balanced equation, the mole ratio between the bromine and the potassium chloride would be 2:1, right? So what I'm going to do is start off again with the moles of the potassium chloride because we're trying now to find the mass of the bromine. So I'm going to start off with the same number here, 0.0241 moles of KCl. And the mole ratio between the KCl and the bromine is 1 mole of KCl down here. I'm sorry, 2 moles of KCl down here and 1 mole of bromine above, right? And then the next conversion factor is where we use the molar mass of bromine to find the mass in grams. So I'm going to put 1 mole of bromine down here. And the molar mass of bromine, again, I'm feeling lazy. I'm just going to type in, whoops, BR2, and that's 159.81 grams. So that would go and whoops, 159.81 grams of bromine. All right, and that's it. So let me do this. Let me do this calculation. So 0.0241 divided by 2 times 159.81. And according to my calculation, this works out to be, when rounded off to 3 sig figs, 1.93 grams. 1.93 grams of the other product, which is bromine. So that's how we do the B product. All right. Any questions about that? Any questions? Any questions? Okay. Before I erase this, let me see if there's any other questions I need to answer in relation to. Oh, okay, so that's it. All right, for that question. All right. So let me clear this. And now we're going to move on to number 60. And just by looking at this, I can tell that this equation is not balanced. So of course we have to make sure it's balanced. So let me hear what you have to say about balancing this equation. How would you go about balancing this equation?
Just put a 2 in front of Cl2.
Put a 2 in front of CO2, and that's it. Let me see here. Zirconium is balanced, silicon is balanced. You have 4 oxygens here, 4 oxygens here. Okay, you're right. So just put a 2 in front of the CO2, and that's it. All right, very good. So the next question is, well, let's see what the question is actually asking. It says, what mass of, this is zirconium 4 chloride, can be produced if 862 grams of, now to be honest, I don't know what the name of this compound is. And 950 grams of chlorine are available. Okay, so let me hear what you guys have to say about this. How would you go about solving this problem? What would be your first step?
Everything the mold,
I'm sorry?
turn everything into molds.
All right, so let's start off with the 862 grams of this compound. Okay, so the first step would be to convert to moles, right? So we're gonna have 1 mole of that compound. And down here, the molar mass. So again, I'm going to determine the molar mass of CrSiO4 and calculate. And I got 183.31. So that goes here, 183.31 grams of compound. Okay, what would be the next step in this process? Now that we have converted Now that we have converted the grams of this compound to moles, what will be the next step? Okay, somebody just said something in the chat. Why did you put 3? Oh, thank you for correcting me on that, Miss Poe. That should be 4. Right here. So. Okay. All right, so what's the next step?
So we can put 1 mole of CrSiO4 on the bottom,
1 mole of CrSiO4 at the bottom.
and 1 mole of CrCl4 on top.
Okay, very good. CrCl4 above. All right. So let's see what that gives. 862 divided by 183.31 times 1. So that gives you, according to my calculation, rounded off to 3 sig figs, that would be 4.70. 4.70 moles of zirconium for chloride. Cr. Oh, by the way, the name of the other compound, which I didn't know, was actually given earlier. Zirconium for silicate. Okay, all right, what's the next step? Okay, so 950 grams of chlorine. We're going to convert that to moles. So 1 mole of chlorine above, and the molar mass of chlorine, which we calculated earlier in another problem, which is 70.90 grams of chlorine. And then what's next step?
One mole of chlorine on the bottom.
Remember the coefficient of the chlorine is 2 in the balance equation. So that should be 2 moles of chlorine down here. All right? And what goes up top here? As a numerator. 1 mole of CrCl4. Okay, so let's see what that gives. 950 divided by 70.9 divided by 2. And according to my calculation, this works out to be, when rounded out to 3 sig figs, 6 point. Let me do this again. I think I may have made a mistake. 950 divided by 7. 4.9 divided by 2. Okay, that was right. Okay, so that would be 6.70 moles of zirconium for chloride. All right, what's the next step?
Choose this limiting reaction, which would be 862 grams here.
Okay, so that's the limiting reactant. But remember the question is asking now, limiting reactant. Remember the question is asking what? What mass of the zirconium for chloride? So how would we get that? How would you get the mass of the product that you expect to get? Well, I think we did one example of that earlier. Yes, sir.
Would you use the limiting reactant and answer for the moles and multiply it by the grams of the ZrCl4 over the
Okay, so you're saying you
mole.
is here.
Yeah,
Okay, yes, I would agree with you. So you're saying 4.70 moles of ZrCl4, and what do you do with that?
multiplied by the grams on top and then the moles on the bottom.
Okay, so 1 mole of ZrCl4 would be below, and you're gonna need a molar mass. Again, I'm going to go to the calculator here. So, ZrCl4. Okay, 233.04 is the molar mass of that compound, which I'm going to put here, 233.04 grams of ZrCl4. And that's basically the setup. And now we do the calculation. So 4.70 times 233.04. And according to my calculation, we round it off to 368. I got 1.10 times 10 to the 3 grams of ZrCl4. Okay, somebody said something in the chat. 2 person actually didn't see. Let's see. Okay. Multiply liquid reactant with the ratio and find, and then the molar. Oh, okay, yes. We just did that. And somebody was asking a question which he later retracted. All right. So that's basically how we do this, all right? So this here is the final answer right here. All right? Okay, any question about this one? Any questions? Any questions? All right, let me clear this. Scroll down. Okay, let me see what this, again, this is another unbalanced equation. And then it says what mass of nitrate can be formed by a combined. Okay, so similar to the question that we just looked at. All right. So how do we go about balancing this equation first? Put a 2 in front of the HNO3, okay? And I think that's it. Don't need to do anything else, all right? What's the next step?
Put everything in the bowls.
So let's start off with the 55 grams of the barium nitrate. I'm sorry, barium carbonate. All right? So we multiply by 1 mole of barium carbonate above as the numerator, and then we need to find the molar mass of the barium carbonate, which is BaCO3. And according to my calculation, that's 197.34. So that goes here, 197.34 grams of barium carbonate. Okay, and oh, let me put a second. What do I do with this next? What's the next step? Okay, let's see, somebody in the chat is saying something. Okay, I'm not sure what you're saying, Miss Cole. Oh, you're talking about the next conversion factor. Okay, my bad. Okay. So you're saying that, well, actually, I would not agree with you because you said that below would be 1 mole of barium nitrate. You're trying to find the amount of barium nitrate, so I would not put 1 mole of barium nitrate here. I will put instead 1 mole. Yes, you're right, it would be up top. So I'll put down here 1 mole of barium carbonate below. And up here, 1 mole of barium nitrate above. And the reason why is because you want these units to cancel out, so you end up with the moles of barium nitrate in the final answer. So let me do the number crunching. 5 divided by 197.34 times 1. And according to my calculation, I got 0.279 moles of barium nitrate. Okay, what will be the next step?
$26 grams of HNO3 to moles.
Okay, 26 grams of HNO3. So we multiply by 1 mole of HNO3. And down below would be the molar mass of HNO3. So again, we need to find the molar mass of HNO3, which is 63.01. So that goes here. 63.01 grams of HNO3 would be below as a denominator in that conversion factor. So next step would be what? What will be the next conversion factor that you're going to put within the parentheses here?
We're gonna put 2 moles of HNO3 in the denominator.
Okay. And what goes above?
1 mole of barium nitrate.
1 mole of barium nitrate. Okay, very good. So let's see what this gives. 26 divided by 63.01 divided by 2. And according to my calculation, this works out to be 0.206 moles of barium nitrate. So what's the next step?
Determine the limiting reactant, which will be HNO3.
Okay, so that's the limiting reactant. And then what? Because the question is asking how much product, how much barium nitrate you expect to get.
Multiply 0.206 by its molar weight.
Okay. So, again, we have to calculate the molar mass of the barium nitrate. So that would be BA, open parentheses, NO3, with parentheses, and then the 2 outside that. And let's see what that gives. That gives 261.34. 261.34 grams over 1 mole for the barium nitrate. And let's see. So 0.206 times 261.34. And according to my calculations, this works out to be equal to 74.4 grams. The mole will cancel here and here. And that's it. That's the answer for number 17. Right? Any questions about this one? Any questions? Any questions? All right, let me see what's next. Let me clear this first. Okay, now this one has to do with yields, percent yield, theoretical yield, and all that good stuff. So, okay, so they gave me the equation, which I think is not balanced, so we have to balance it. In fact, if I'm not mistaken, we got this equation before. From a previous problem. In any case, it has to be balanced. So how do we go about balancing this equation? Okay, 2 here.
3 for oxygen,
Okay,
2 for ZN,
okay,
and 2 for S.
okay, yeah, so yeah, that's the equation that we worked with earlier. Okay, so the question says, if the typical yield is 86.78%, how much SO2 would be expected if this mass of zinc sulfide is used? So we're going to start off with the 4,897 grams of the zinc sulfide, right? And the first thing I will do is convert that to moles. So 1 mole of zinc sulfide will go above, and the molar mass of zinc sulfide is 97.46. So that goes here, 97.46 grams of zinc sulfide. All right. All right. So the next step is what? Okay. So now we're going to look at the mole ratio between the SO2 and the zinc sulfide based on the balance equation, right? And based on the balance equation here, there's a 2-to-2 mole ratio between the sulfur dioxide and the zinc sulfide. So that would be represented here in the next conversion factor where we have 2 moles of SO2 and 2 moles of zinc sulfide. And then we do the calculation here. Actually, one more step is needed. And that would be to find the grams of sulfur dioxide. So that means you have to multiply this by the molar mass of sulfur dioxide, which is 32 point something. Let me get the exact. So that would be SO2. And so that would be 1 mole of SO2 downstairs. And upstairs, you're going to have 64.06 grams of SO2. All right. Okay. So now we can do the number crunching here at this stage. So it would be 4,897 divided by 97.46 times 1 times 64.06. And according to my calculation, this works out to be equal to 3,219 grams of SO2. All right. So that's a mass that you expect to get. This here would be the theoretical yield, right? Because on paper, like what we just did, this is the amount of product you expect to get, right? And as I'm quite sure I covered in the videos for this chapter, I made mention of the fact that even though you might expect to get a certain amount, the actual amount that you get when you do the experiment is oftentimes less, right? And that would be the actual yield, right? So the theoretical yield represents the maximum amount of product you would expect to get based on your calculations. But the actual yield is, as the term suggests, the amount of product that you actually get when you do the experiment. So the question, now remember now, the relationship between the actual yield and the theoretical yield is percent yield is equal to the actual yield divided by the theoretical yield, right? What the question is asking for is the actual yield, right? So if we rearrange this equation, you're gonna get actual yield is equal to the percent yield multiplied by the theoretical yield, right? So the percent yield is given as 86.78 percent divided by 100% times the theoretical yield, which is 3,219 grams. So let's see what that gives. 86. Oh, I forgot to mention here, this should be times 100%, which means that I should have divided by 100% here. All right, okay, so as I was saying, 86.78 divided by 100 times 3,219, and according to my calculation, this works out to be equal to 279. Oh, wait a minute, I did something wrong. 3,219 times 86.78. Wait a minute. Oh, divided by 100. So this will be 2,793 grams, and that will be the answer. All right. Okay, any question about this one? Any question? Any questions? Any questions? Any questions out there in Zoom? Okay, let me clear this. Let me see. Oh, 115. All right. Whoops. Let me. Okay. You know what? Let me see here. Let me look at 19. Okay, you know what I'm gonna do? I'm gonna leave the rest of these for you to do, all right? Because they're very similar to the ones that we did before. So what I'm gonna do now is open up a Dropbox. Or I think I opened a Dropbox already by mistake, actually, to be perfect honest. I think somebody sent me an email, or maybe it's another class. Oh yes, so I did open up this Dropbox here by accident. So I'm going to make some corrections to this here. So today is the 4th. I'm going to let the deadline for this be the 6th. All right. So let me do this here. So this is available from now. Oh, look at that. Let's see here. Okay, no problem. So yeah, the 6th. All right, so let me save it now just to make sure. And okay, so it's published. We'll just do one quick check here. Okay, so it's set up now, so you should be able to upload your assignment into that particular Dropbox. All right. All right, so that's pretty much it for today, folks. I'll see you guys next next Tuesday. All right, let me
It's the next Tuesday, better, and better.
Is that a holiday? It's probably. That's a good question. Let me check something here. I don't think.
Yeah, check it out.
I don't think it's a holiday recognized by the college, but let me check that. See here. Um. Okay, so. Oh, the college is closed, I didn't realize that. All right, so I'll be seeing you the week after that day. All right, so no classes next week, Tuesday. All right,
Question for question number 17, page 10. You ended up saying that the final answer was about 74-ish. I just scribbled it down real quick.
I'm sorry, repeat that.
Um, you said that the answer for the mass of barium nitrate or BaNO3,
Uh-huh,
you said it was something like 73 or 74 grams. I wrote that down real quick and just put a pin in it, but like every time I did the math on paper and on calculator, it was around 53.82. And I'm not,
oh, okay.
I'm missing something.
Check
So
some-
sorry.
Sorry, because you could be right. And somebody just said something in the chat saying that it should be 53.8 grams, but so that could be it. I'm going to look up the answer key here.
All right, you might want to hide your screen or something then.
This is number, what is it?
It's number 17, page 10.
Number 17.
My dog's barking, let me mute.
Oh, okay, I got, okay, apparently the actual answer is 55. And maybe, I don't know what the error is on my part, maybe it's the monographs, I'm not sure. But the answer should be 55, which kind of is close to what somebody said. Somebody said in the chat that it should be 53.8, so. I will look at it again and make sure it's right, and then we can revisit this question next class. All right,
Thank you, sir.
no problem. Okay, so I'm going to leave out from the Zoom link right now, so I'll see you guys next class, all right?